Section 425 is called Commutator and brushes. Let's look how they're designed and how they uh, work in relation to the design of the DC generator. We're told that the commutator is composed of an assembly of tapered copper segments that are insulated from each other. Of course, this commutator is a part of the armature. You know, it rotates with the armature, but this is the tapering that it's talking about, and this would be where the insulation is placed, and each one of the coils is connected to the appropriate commutator slot. He's indicating that perhaps mica is used as that insulator between those two slots, and the armature conductors are connected in a way that you know, gives us the proper voltage output that we expect when this machine is operating. He says that a great care is taken in building the commutator because it's a critical part of this machine. You know, you want to eliminate any arcing or sparking that might occur with that, and so it's a critical part of this DC machine. The construction of it is. When we look at some of the brushes, this would show the brushes of a two-pole generator, and notice that the number of brushes match the number of poles. This is a six-pole generator, and what I do want you to notice on this is if you look into the detail here of all the positive brushes are connected together and all the negative brushes are connected together. So, those are connected together to get the overall positive terminal and the overall negative terminal. The brushes are made of a carbon material that is conductive, but at the same time, it is able to endure and wear with the rotation of that armature. There's a spring load to the brush to keep a constant pressure as that armature is rotating. And you can see here, and I'll kind of blow this up a little bit for us. Here's a brush set, and here's the commutator segments here. And here's those springs that basically press that brush up against that armature as it rotates, and they do wear out. And so, these brushes, one of the drawbacks of a DC machine is the required maintenance on the DC machine, and these brushes have to be replaced over time. So, that's one of the things that is discussed. He also goes into this idea that that there's sort of a critical component of applying the proper pressure to these brushes as they connect to the armature. Without that proper connection there, again, you get into this problem of arcing and sparking and those types of problems. Okay, so just a little bit about the brushes and how they're constructed. Let's see, is there anything else? Yeah, let's look at this for a second. This is a four-pole generator, and I think it kind of helps us see, all of this in, one assembly. Now, this is a very large generator, and it's a 100-kilowatt generator, and it's got four poles, so we ought to be able to distinguish, four distinct magnetic pole constructions in here. This, of course, would be the armature mounted on the shaft. We'll see that these shafts have keys on them that we use to connect different things to. Here's our commutator segments here that we see. Here's our brushes across there. So, again, we don't want to get into, excruciating detail on the construction of these machines. We're not trying to design them. We just want to make sure that we understand them and we recognize the different components for when those times come to where we're interacting with these machines. So that gives us a, a little overview of the field and the armature and the commutator and the brushes.